So now that we've talked a little about linear combinations, I'm going to introduce what's known as span. That's span. So we define, definition. We define the span of a set. So we define the span of a set S. Okay, so S is an arbitrary set of elements where S is a subset. So S is a subset. This is the linear algebra, or just the notation for subset in mathematics in general. So we define the span of a set S where S is a subset of V, and V is a vector space. V is a vector space. So we define the span of a set S, where S is a subset of V, as the set of all the linear combinations. The linear combinations of elements of S. So we've seen in previous videos that we can express a vector in terms of different vectors, and that makes it a linear combination of those vectors. What span is a more general definition. It's a broader statement of linear combinations. It's all of the possible, so any of the possible linear combinations in a set S. So it's anything that we can so it's any scalar times the element plus any scalar times another element in S. So we can add those how many times we want. It's the set of all the possible linear combinations of elements of S. Okay, so another way to write this, so the notation for this is we write span S. So this is the notation for span of S. This is the notation for span of S. We write span of S as, so equals, the linear combinations of all the vectors in linear combination of all the vectors in S, so that is C1 V1 plus C2 V2 plus ... plus Cn Vn, such that, or where V1 through Vn belong to S. So the elements V1 through Vn are all elements of S, and C1 through Cn are all elements, or are all real numbers or scalars. So that's the definition. It's the definition of span S. It's all of the possible linear combinations. So this is any possible linear combination because it's any of the possible vectors or elements in S, and any scalar belonging to the real numbers. Now let's just do a quick example. So let's do a quick example. So if I have a set S that's 1 0 0 1. So if I have this set of two vectors, and I ask you what is span S? So what does span S create, or what is the result of all the linear combinations of 1 0 0 1? Well, let's think about it for a second. You can write, let's say you can write 2 1 as 2 times 1 0 plus 1 times 0, 1, right? That's fair. You can also write minus 1, 2 as minus 1, 1, 0 plus 2 times 0, 1. You can also write 112 and minus 79 as 112 times 1, 0 plus minus 79. Whoops. Okay, let's just rewrite that. 112 times 1, 0 minus 79 times 0, 1. Right? So you can write any vector in R2. That is, R2 is just the set of vectors. So R2 is just the set of vectors that can be represented as A, B, such that A, B are both real numbers. So this is a vector space actually. R2 is a vector space. So you can write any vector in the vector space R2. You can write any vector space in R2 as you can write any vector in R2 as a linear combination of S. Okay, so and that's because you can write A, B as A times 1, 0 plus B times 0, 1. So as a result, what this means is that the span of S, so the span of 1, 0, 0, 1, the span of, and this is S, span of S is actually all of the possibilities of R2. So it's any vector that belongs to R2. So in effect, that means that span of S is actually equal to R2. It's the set of any possible vectors that can be written in the form A, B. So that can be written like this, because it's quite clear that you can write A, B as A times 1, 0, A times 1, 0 plus B times 0, 1 for whatever A, B. So that's the basic definition of what it is for something of what it is for a span to span a set. To span a set just means that you have the set of all possible linear combinations of the vectors in that certain set.